Alright, welcome back to 30 Days Python Challenge to help you improve your problem solving skills, and today is day 6. So today we are going to be working with prime number. Alright, so talking about prime number, we want to write a program that checks if a natural number is greater than 1 and if it is divisible by 1 and itself. So it has to be greater than 1 and it has to be a prime number. So we have to just input a number and then the output is either prime or not. That's divisible by 1 and itself. Divisible by 1 and itself in that sense. So right, so what is going to be the thinking process right here now? So the first thing I would love to do here now is to check the number. So you should just check if the number is, so if n is greater than 1, that's the first thing I want to do. If n is, at any point, if n is less than 1, that means it is not prime. It is not prime as of that time. Then what I can do next now is to check if it is divisible by 2 to the square root of n. And the square root of n is the square root of n. So I want to check if it is divisible by 2 to get to the square root of n. So check if it is divisible by 2 to, from number by 2 to the square root now of n itself. N itself. And if it is divisible, if it has a number that is divisible between those two range, it is not a prime number, else it is a prime number. So now let's get into the code. So the first thing I have to do, as always, is get my input from the user. So I'm going to go ahead and say just int input. So input now, I was going to come here and say enter the given natural number. So if I say enter the given natural number, what's the next thing I want to do? So the next thing I want to do is say if n now is less than 1, I want to go ahead and print f right here. Alright, n is not a prime number. So at any point in time, if this is less than 1, n is not a prime number. So that is constant. If it's less than 1, we are not looking for the prime number of a negative number. That is not possible. Then else, I want to define a variable called is prime, and initially I'll set it to true. So now is where I check the number between the square root and between 0 and the square root of n and 1. So I'll say for I in range, and I'm checking, don't forget I'm checking from 2 and the square root of the number itself. So for I in range 2 now and int, so this is n right here. To check the square root, you can just multiply by 0.5 itself. So if I multiply by 0.5, that's it. So now, at any point in time, I'm checking if this n is divisible by 1, by I. So if there's any point that I'm able to divide n by 1 and I don't have any remainder, that means it is divisible. So I'm just going to go ahead and say is prime here is false. Right. So its prime here is false, and I'm just going to break out of the loop once I get a number that is divisible by divide n. That is all. I'm breaking out of the loop itself. Then I'm just going to come here and say if it's prime. So if I have looped through it all and it is still prime, so I'm just going to come here and say print f, and I'm just going to happily say n is a prime number. Just like that, right? Then else, I'm going to go ahead and say print n is not a prime number, which I will just copy from there as a lazy programmer. Right, so let me just enlarge it so we can see all this now. So we see our code right here. We are getting the n input. We are checking if n is less than 1. If it is less than 1, it is not a prime number. And we are defining a variable is prime is true. Then we are looping through a range of value from 2. Now, because all number is divisible by 1, right? As a constant. From 2 now we are looping through this number from 2 to the square root of this number itself. So that's the range. So let's say if this number is 4, we are looping from 2 to 2. If this number is 16, we are looping from 2 to 4, because you know that as it is 16, 2 will be able to divide it. So that's already like out of it. It is not a prime number. 16 is not a prime number. So if we should go ahead and run this now, I can enter 1 here. 1 is a prime number. Let me just run that again. And if I should enter 2 here, 2 is a prime number. And what we are putting 3 is a prime number. And when we get to 6, what happened? 6 is not a prime number. That's because we are looping through 6 now. Okay. Okay, we are looping through 6 now. Alright, square root. This is meant to be double asterisk. Yeah. Because this will still work in a way, because we are just looping through half of the value itself, not the square root. So it's going to consume more time. And when you're creating algorithms, you have to put your time in consideration itself. So run that again now. If I will go through something like, if I have something like this now, it's going to be looping through half of it when it was still just a single asterisk. But now that it is square root now, we are only looping to like square root of this value itself. So this is not a prime number. Alright, so we can see that in action and how that works well. So that'll be all for challenge 6, now prime number. So I hope you give it a try and write in the comment section, were you able to get it on your first trial or you had to watch the solution. See you in the next challenge. Bye.